So this video is J24 and it's all about simplifying complex rational expressions, which if you want to think about it, it's like basically a fraction within a fraction, right? The top of the fraction has fractions, the bottom of the fraction has fractions, or either or, right? So normally if we were going to solve this, we would have to combine the two fractions on the top to make one fraction, and then combine the two fractions on the bottom to make one fraction. And then once we have it as one fraction divided by one fraction, we can flip and multiply by the reciprocal, which is a whole lot of work, right? So we're not going to do it that way. We're going to do it a different way. What we're going to do is we're going to use this idea that if we multiply by 1, it doesn't change the value, right? If I multiply anything by 1, it just stays whatever it was. So what we're going to do is we're going to figure out what a common denominator would be for every single denominator that's shown in here, okay? And then what we're going to do is we're going to multiply the least common denominator as a form of 1 to the entire expression, okay? So let me show you what that looks like. On this one, the first thing I want to do is figure out what is my least common denominator. Okay, what is my least common denominator that is a denominator for every single denominator within this rational expression? So if I look on the top, I need an A and I need a B, right? So I need at least A and B for sure. On bottom, I need an A cubed. Well, A cubed would definitely take care of A to the first power, right? And I need a B cubed. And B cubed would definitely take care of B to the first power. So I'm going to go ahead and say here that my least common denominator is A cubed B cubed, right? Because A cubed would get rid of the A cubed, B cubed gets rid of B cubed, and A cubed and B cubed also would get rid of A and B to the first power. So what I'm going to do, and I'm just going to write this out to the side. You don't have to write this if you don't want to. But basically what I want to do is I want to do 1 over A plus 1 over B all over 1 over A cubed plus 1 over B cubed times, I want to multiply by 1. And remember, if I multiply anything by 1, it doesn't change the form. And I can actually multiply by 1, instead of writing a 1, I can write any value over itself. So I want to multiply by A cubed B cubed over A cube B cubed, right? Because you agree this is just equal to 1. So I'm not changing the value. I'm just multiplying this whole mess by 1, right? But what's cool about multiplying it by this is, here's where you want to start writing, is when I multiply top and bottom by A cubed B cubed, it's like distributing this A cubed B cubed to both terms, right? So it's like saying I have A cubed B cubed times 1 over A plus A cubed B cubed times 1 over B all over A cubed B cubed times 1 over A cubed plus A cubed B cubed times 1 over B cubed, right? So when I say I'm going to multiply by this on top and bottom, I'm basically saying I'm going to multiply that least common denominator to every single term on top and bottom. And here's why we want to do that, because look what happens. When we do that, we can now reduce away all of our little denominators. So here's one A that I can reduce with an A here. If I take away an A, I would have an A squared left, right? Here, if I reduce by B, I can reduce a B here, which would leave me with B squared. And then in the denominator, my A cubes cancel on the first term, and my B cubes cancel on the second term, right? So now what I'm left with off of the first term is my A squared, right? A squared B cubed times 1, which is still just A squared B cubed. My second term on top, I have A cubed and I have B squared. Right? And then on bottom, what I'm left with is B cubed. So B cubed And on this term, I have a cubed plus a cubed, right? So that's a lot easier to look at than our original, right? So we take our least common denominator, we basically multiply it by every single term, right? You can write out this step just so that you know you're multiplying by a form of 1. I'm not going to require that you write this step. Basically, I just want you to know that you're taking that least common denominator and multiplying it by every single term on top and bottom. Because when you do, all the little denominators should cancel out. And now we just have a rational expression that we need to simplify. Okay, so if we want to simplify it, we basically need to factor it. Okay, in order to see if it simplifies, we need to factor it to see if we can cancel common factors. Okay, so if I look at the top, on the top, I definitely want to pull out a greatest common factor, right? So greatest common factor for the top would be a squared b squared. So if I take out an a squared b squared, from the first term, my a squared would be gone. If I take off a b squared, I would be left with just b, right? If I take off a squared b squared off the second term, take off an a squared, I'm left with just a single a. And then if I take off b squared, my b's are gone. Okay. Notice I'm not left with anything squared or cubed, so that's as far as I can go on the top. Okay. So then on the bottom, I need to see there's no GCF. Okay. On the bottom, there's no greatest common factor, but I notice that both terms are cubes. Okay. So notice this is a sum of cubes. Okay. Because my base that's being cubed here is b, and my base that's being cubed here is a. So remember, our sum of cubes formula states that you take our first base plus our second, so b plus a, times our first base squared, so b squared, minus our two bases multiplied together, so b times a is ba or ab, however you want to write it, plus my second base squared. Second base squared is a squared. Okay. So now that I have it completely factored, then I can cancel common factors on top and bottom. So here I have a b plus a and a b plus a on top and bottom. So that means I'm left with just a squared b squared on top, and on bottom I have b squared minus ab plus a squared. And I cannot reduce this because two things. One, remember when we use our sum of cubes formula, this second quantity is always prime, or in other words, it's not factorable. Once we plug our bases into our sum of cubes formula or our difference of cubes formula, this is as far as it goes. This term is no longer factorable, right? And because all these little pieces are stuck like glue with these plus and minus signs, I can't cancel the b squares or the a squares because this is all one unit. Okay, so if I can't cancel that whole unit, I can't cancel pieces of it. So this is my final answer. Okay, so really from about here down, this is stuff that we've already been doing, right? We know how to take a rational expression, factor on top and bottom, and get left with an answer after we've canceled common factors. The only new thing that this section is adding on is that when we have a fraction within a fraction, the way that we make it a little bit more manageable is we figure out what the least common denominator is for all denominators included in this expression, and we multiply every single term by that least common denominator so that we're left with something that we can factor. Okay, let's look at another one, see if we can get the hang of it. Let's look at this one. This one is w plus 8 over w squared all over 1 plus 2 over w. So the first thing I want to do is make sure everything has a denominator. So notice this w is a regular constant term, right? It doesn't have a denominator written here. So it's implied that this is w over 1. Same thing with this 1. This is like a 1 over 1, right? So looking at all of the denominators, I need to figure out what would be my least common denominators for this whole mess, right? Well, for this denominator, I need a 1, right? I'm just going to put a 1 here, right? And I need a w squared, okay? W squared. On bottom, I need a 1. I already have the 1, right? And I need a w. Well, w will cancel out with w squared, so I don't need to add on another w, right? And really, 1 times w squared is just w squared, right? So w squared is what I want to multiply to every single term of my original. So my original is w plus 8 over w squared all over 1 plus 2 over w. I'm just rewriting it, okay? So what I want to do is I want to take my least common denominator and I want to multiply it by every single term. So I'm going to multiply this one by w squared. I'm going to multiply this one by w squared. Multiply this one by w squared. And multiply that one by w squared. Because if I multiply every single term by w squared, I should be able to cancel out all my denominators, okay? So let's see. When I look at this one, I don't have any denominators to cancel out. So I just do w squared times w to the first, which gives me w cubed, right? On this term, my w squareds cancel. So those cancel out, and I'm left with just a positive 8. And on bottom here, I don't have anything to cancel, just w squared times 1, which is w squared. And on the second one, I can cancel 1 w. So the w from the bottom is gone, and I'm just going to take one of the w's off here, which leaves me with a w to the first power. So I'm left with a 2 and a w, so plus 2w. Okay? So that's much better than what I started with, right? Now all I need to see is if I can factor and reduce, okay? I'm just going to say factor. Okay, so looking at the top, I have 2 terms. Now a sum of squares I can't factor. Luckily, this is not a sum of squares. This is a sum of cubes, right? Sum of cubes. Okay, if y'all are not remembering these difference of squares and sum of squares formulas, you need to go back and visit that unit, because those are not formulas that will be given to you on the test. Okay, so our base here that's being cubed is a w. Our base here that's being cubed is a 2. And our sum of cubes formula says that we do our first base plus our second, so w plus 2, times our first base squared, so w squared, minus our 2 bases multiplied together, so w times 2 is 2w, plus my second base squared, so 2 squared is 4. Okay, and remember, this one's now prime, right? I can't factor that any further. And then on bottom, the first thing I always look for is the greatest common factor. So greatest common factor, what they have in common is a w. And if I take out a w, I'll be left with w plus 2. Okay, so you can clearly see that I have a w plus 2 on top and bottom. And once I cancel that out, I will be left with w squared minus 2w plus 4 all over w. This one doesn't factor any further, and I can't reduce this w because all these terms are stuck like glue with these plus and minus signs. So it just stays like that. Okay? Let's look at one more, and then I will have y'all try some. So first thing I want to do, remember, is find the least common denominator for this whole expression. So I look at all of my denominators. I have a b to the first power, an a to the first power, an a to the first power, and a b to the first power. So I definitely need an a, and I definitely need a b. If I multiply that by all these terms, I should get rid of every single denominator, right? So I'm going to go ahead and write what I have. So I have a over b minus b over a all over 1 over a minus 1 over b. And I want to take that least common denominator and I want to multiply it by every single term. So I'm going to multiply this one by ab, multiply this one by ab, multiply this one by ab, and multiply this one by ab. Oops, not a plus b. What am I doing? Making math more interesting. Doo-dah, doo-dah. Just kidding. Okay, so now that I've multiplied every single term by the least common denominator, all of my denominators should cancel out. Okay, so let's look and see what that leaves us with. So on the first one, my b's cancel out, and I just have a times a. So that's going to give me a squared. On my second term, my a's cancel out, and I just have b times b. So I'm left with a minus b squared. Okay. On bottom, my a's are going to cancel out, and I'm left with b times 1, which is just b, minus on my second one, my b's cancel, and I'm left with 1 times a, which is a negative a. Okay. That wasn't too bad, right? Now we just need to see if we can factor and reduce, right? So we have to check. So when I look at the bottom doesn't factor, right? This is just like a monomial minus a monomial, and they don't have anything in common. I don't have anything squared. So right now I don't think I can do anything with the bottom. So let's look at the top. The top, I don't have a greatest common factor. So then I'm looking for squares or cubes if I only have 2 terms. And here, both terms are perfect squares, right? So that means I have a difference of squares here. Difference of squares, I need to identify my bases. My base being squared here is an a. My base being squared here is a b. And remember, a difference of squares factors into my first base plus my second base times my first base minus my second base. Okay. And then on bottom, I have b minus a. And I'm going to put it in parentheses just because it's a quantity. So when I'm looking at all of these, I actually don't have any that match, right? I don't have any that match. I have, these are both 2 positive terms, right? These are not positive terms. And these actually have one of each, a positive and a negative term, but it's not the same, right? Here A is positive and B is negative. Here B is positive and A is negative. So if they're exactly the same other than the signs, I can go ahead and factor out a negative, right? So in other words, I'm going to leave the top the same, a plus b, a minus b. And on bottom, I'm going to factor out a negative 1. So I factor out a negative 1, that's going to change the signs. That's going to make this a negative b and a positive a, right? Take out a negative to change the signs. Okay, so now these 2 quantities actually match, right? Because I have a positive a and a negative b. Here I have a positive a and a negative b. It's just written in the reverse order, but they're the same. So I can go ahead and reduce that. So what I'm left with is a plus b over negative 1. And remember, when we divide by a negative 1, all that does is change the signs. So I'm left with a negative a minus b. And that's it, right? If I divide both of them by negative 1, it just changes their signs. Okay, so there are, how many are there? There are 2 for y'all to try. So go ahead and pause the video and work on those. Once you're done, or if you get stuck, unpause it and we'll go over it. Okie dokie, let's look at number 1. So on number 1, when we look at all our denominators, we just have x's and y's to the first power. So we should be able to get rid of them with an xy to the first power, right? So I'm just going to multiply every single term by xy. When I do that, every denominator should cancel away to where I'm just left with x squared minus y squared, over x plus y. And notice the top of it is a difference of squares. So with a base of x and a base of y, that means it's going to factor into x plus y and x minus y. And then my x plus y's are going to cancel. Okay? Excuse me, if I'm going fast, feel free to pause it. Go through this at your own pace. Number 2, when I look at my two denominators, I have an xy in the denominator and a y in the denominator. So x to the first power should get rid of the x's. Y to the first power should get rid of the y's. So again, my least common denominator is xy, and I'm going to multiply it by the terms on top and bottom. So notice here, I didn't have to do it to the x squared and the y squared, because the way it's written, this is all one term. So I'm just going to multiply this whole thing by xy. Okay. When I do that, my xy's will cancel. I'm left with x squared minus y squared on top. On bottom, my y's cancel, and I'm left with x times x minus y. And I did not multiply it because my next step is to factor and see if I can reduce. So since it's already written factored here, we don't need to distribute the x, right? Because then we would just end up pulling it back out as the greatest common factor. On top, we have a difference of squares. So again, x plus y times x minus y, and then our x minus y's cancel, all right? Okay, so that is the end of, what is this one? J20 something. J24, which is simplifying complex rational expressions. So you should now be able to complete this section of homework. If you get stuck, if you have problems, please let me know.